Hi, thank you for joining me today, and thank you for Hacking the Box Singapore to invite me to talk about malware protocol simulations in distributed networks today. So I will talk about malware simulations today, but the point here is actually how we can simulate this in blue teamers perspective. So the question here is how can we safely simulate the malware and adversary network traffic to assess our data analytics, telemetry, and defense solutions? This type of question is always there, and I have actually heard about similar things from different parties that includes blue teamers, data analytics, different security engineers, and defense people. So I will try to explain today how we can simulate all these activities in defensive point of view using the tools that can be utilized by the defense people. So today we will talk about malware communications and how they work. After that, we will talk about cyber analytics for detecting this type of malware communications, ways to generate the malware communications, and of course, I will talk about TESAT today as well. My name is Fatih Ozavci. I'm an adversary simulations specialist. So I work for the Missing Link as a security consultant. So I have provided similar research in my specialty, this adversary simulations area. So I have different tools such as TESAT malware generator, Patak C2. I also prepare TA505 plus adversary simulation pack, and we will talk about all of those during this talk. I have previously reported some vulnerabilities to major vendors as well, and I have presented in various security conferences, including Hacking the Box, but also Black Hat, DEF CON, and some other conferences in the same area as well. So we always see some sort of threat actor campaigns, and we see that XYZ is breached, and that network has been compromised, or this data has been stolen. But this always happens everywhere. The point here is how we can identify them during our networks, right? But the problem there is also how they stay that long in our networks. So we will try to find how they move inside and how we can generate our IOCs based on this type of stuff. So this is an example of SolarGate. So during the SolarWinds compromise, Nobalium threat actor, as named by Microsoft, has provided a different approach, and they stayed inside for a long time. They planned the exercise in advance, and this is more like a year of run. So simply they started around September, and they ended this in the end of the year, and they commenced it. So simply they developed tools, they compromised the supply chain, and then they allowed the supply chain compromised patches to distribute to the victims, and then they decided to wait for the right victim to see the right environment as well. So this is how it works for the threat actor's perspective. But 8 months, 9 months, or a year waiting period is too long. They do that because their actually intents are slightly sensitive. They try to compromise the government or some sensitive organizations. So simply they are trying to go subtle as much as possible. In this exercise, they try to identify the victim, and they do nothing before they identify the victim, and that avoids actually all detections because we can't easily see how they behave, and we don't see any malicious activities before the victim is identified. So we need to see some sort of communication in our network that should not be attached to a threat actor, but also checking a kind of C2 instruction. It's more like a sleeper cell. They utilize this using the DNS services. Then after that, they used a stage deployment, and they didn't use directly Cobalt Strike for it. They used their own C2 to deploy this second stage, and then they invoked the Cobalt Strike to make this interactive as well. So before Cobalt Strike, you have other problems as well. So simply you need to understand how they compromised you, how they stayed in this network as a sleeping cell, what actually beaconing ratio will be sufficient for you to identify this. Also, how this stage deployment works. Can you identify this? If so, can you repeat this as well? Because most of the blue teamers use different tools. Some use Security Onion, some use Splunk, some use Hadoop, some use Exabeam. So they have different telemetry. They have different network requirements. That's why simulations are important to give them almost all these opportunities to simulate the activities. In this case, we need to understand the threat actor perspective. They identify the organization, they identify people, they after that find the most valuable things, and they try to steal this. All this process takes that long. So we can identify some of those activities, or we can simulate them better to see our telemetry works or not. There are different types of adversary simulations, of course. There is red team, and it is a covert operation of the adversary simulations. They don't tell anything to the blue teamers other than some white team members, such as executive committee. And they perform an adversary simulation in that context. So simply, we see this, and it works for some of the exercises. But blue teamers, they do not get improved very fast during the exercises. On the other hand, purple team-like exercises, they actually invite blue teamers to the exercise. It's a collaborative exercise. Simply, they run the exercise in both parties, step by step. For example, we executed the initial compromise. Would you please confirm you have telemetry on it? Okay, we executed the situational awareness or privilege escalation or lateral movement activities. Would you please confirm that as well? So it is more like a kind of interactive activity for everyone, and they try to keep all the logs, all the activities and telemetry, and they need to share it, and they need to train themselves. One other type is also important. It is called generally breach or threat simulations, and they are automated simulations generally, and they actually utilize some of the IOCs to actually ring the bells for telemetry. They are not that realistic, and they will try to give you some indicators of compromise to make sure that your telemetry is there. But you don't know whether or not that telemetry is based on an IOC available in real life. So simply, the threat actor will change their implementation, and in this case, you need to check your telemetry back again. So when we run a red team exercise, it takes time, sometimes ages. It starts with maybe 1 or 2 months. It may go to 6 months activity as well. It's pretty much like the adversary simulations and adversary threat actor activities as well. So just like Nobelium, it may take a year. So it depends on the objectives of the exercise. However, it is not easy to rerun for blue teamers, and we can't easily learn almost all of those. So we need to break this down and make it actually eatable, chewable for us. Cyber analytics, in this case, most friendly approach, and advanced cyber analytics help defenders to identify various indicators of compromise in the organizations, including their telemetry, including their maybe endpoint activities, some managed services, and that there are several different tools that can be utilized in this advanced cyber analytics. Sometimes you use data sources coming from endpoint, server, or network monitoring. Sometimes you use a managed actually service provider that can deploy this data to you, or you can use commercial services that can record and generate this data, ingest to your data analytics platform. So different types of activities will happen. But the thing is, we have a process here. We need to set a good telemetry. We need to ingest this in real time as possible, as much as possible. And after that, we need to build our own detections based on the pool available in this data analytics environment. So simply, we need to understand how it works. In this case, we need to test ingestion, we need to test telemetry, whether or not it works, the data sources available or not, or they see those activities. Also, for detection-wise, we may use signature-based detection, we may need to train machine learning or AI. So we have a lot of different things to test in this picture. So cyber analytics is a part of our cyber defense world, and we need to test almost all of those in that manner. So training exercises or testing them is quite important. So Mitra actually provides a good map, and I cut up actually some portions of this map which could be relevant to our talk. We see some of the C2 activities and exfiltration activities here. They are related activities for this talk because we will talk about malware communications and how we can simulate them for the data analytics and defensive perspective. So we need to focus on this type of C2 activities that includes actually some sort of beaconing, also real-time communication, tunneling, data exfiltration. So we have different options for the C2s. Sometimes it is interactive, sometimes it is go subtle, such as DNS or maybe through a social media as well. This has been used by different threat actors. For example, Turla was using social media to identify things. Also, Nobelium was using Cobalt Strike for the interactive activities. So everybody was using different types of tools, but there are some common things. So we will discuss about how we can simulate these common things today. So, adversary simulation activities can be actually handled in two different categories. One is collaborative, the other one is automated one. I will not talk about red team activities today because it is not easy to run a red team activity only for seeing telemetry or cyberanalytics work because it takes time consuming, but also resources are expensive, and it will be also not efficient to fix the errors on the way because you won't see any activities before the exercise completes. You will see some activities that could be actually a real threat actor or the consultants performing the adversary simulation. So you can't differentiate them unless you have attribution. That's why the red team is out of scope for this talk. We will focus on two types of the activities. One is the collaborative exercise that could be actually quite useful for you, and they are called generally with colors such as purple team exercises, but we can easily call these collaborative adversary simulation exercises or adversary emulation exercises. Simply red team and blue team, they work together, which is great to develop actually more capabilities there. And there are really good upsides there. First, you need to work on the threat intelligence data together. You need to actually find the data analytics cases, and you can deploy this for the defense perspective. You can actually assist to the red teamers to commence the exercise instead of waiting for a phishing email for 2 weeks or maybe a couple of months to run. You can just assist them to give a consent to run a laptop and run the execution phase or open the document. So it can start with an assume the breach principle. So it will be quite useful for this case. And you can actually manage the hostile activities as well because you can contain the issues. You can say that this server must be tested, this endpoint must be tested, these activities must be replicated. This is quite important. There are downsides, of course, because whenever you go to this type of communications, you won't see the cyber defense actually behaviors, instincts, because the thing is they will know the exercise. That's the kind of downside. Second downside here is actually regarding the red team, because red team won't use exactly all the realistic tools to avoid you. For example, domain fronting or hiding the activities, performing a supply chain attack distributed to months. So you will need to make this realistic, but eventually this will be slightly different from the real life actors. The other thing is you can't easily give full opportunities to the red team to compromise your entire network. That is not possible. Also, that is not exactly logical either, because we know that you don't have telemetry everywhere. And the second thing is you can't easily allow to compromise the entire organization because you are just a cyber defense team. So sometimes you try to defend some servers or resources that you have no access to. So you have only the endpoint tools installed on it or server tools installed on it to remotely get telemetry. That's it. You can't give any consent to test them. If that is the case, you need to supply some nominated systems, designated systems to run this exercise. This actually limits the capabilities of the red team. So you need to see that red team will simulate the activities slightly realistic, but to well-known targets. And they will also know that where to go, which is also another limitation. So offensive mind is there, but partially, because for the adversaries, they will try to chase a target. If they are, let's say, short of time, behind of schedule, they will use highly noisy activities that could be even remote exploitation or maybe denial of service attacks because they need that objective to run. However, in your collaborative exercise, you can't be hostile like that. You need to think about how we can utilize these activities. And offensive mind is a kind of problem because you can't always find the red team. So this is time consuming and resources are expensive again. Those are downsides. On the other hand, for the automated traffic generation, you don't have some of those limitations. So you can use realistic tools. You can use direct indicators of compromise. You can actually extract from the threat intelligence. And you can actually provide realistic lateral movement because you can actually replicate the exploitation attempts with their signatures and other stuff as well. And you can repeat this. And you can also use a kind of C2 and you can actually mask this as well, just like the other ones. So they are actually almost same for the upsides. Actually, automated traffic generation will give you more opportunities in some cases. But of course, there must be a driver. Downsides are just Again, this is an automated environment, so you may have limitations of software, you may have compliance violations, so you need to pay attention to those compliance violations. That's why you need to follow some certain execution schemes. You need to actually nominate some software to perform this. You need a software suite to run this accurately as well. For example, interactive communications, stage deployments, C2 communications. And sometimes even you have no access to those offensive tools, right? Because you are defense. And cyber analytics people do not run COBOL Track daily. So that is not logical either. So someone needs to give you those tools. And that is not always possible because of the license restrictions. So you need some tool sets and you need to be armed to do that. That is the downside of it. There are some solutions, open source and commercial. Today, I will talk about my solutions only. But there are, of course, lots of different commercial solutions here. Skype, Attack IQ, or open source Caldera, for example. They are the tools that can help you to simulate some of those activities as well. So pay attention to those tools if you are looking for some commercial solutions and vendor activities. But today, I will talk about my open source solutions and try to arm you to test your initial environments, draft environments, maybe data collection environments, but that's it. In production use, my tools will be not sufficient for you. So how we will operate this? So for the collaborative exercise, we can actually follow a certain scheme and certain steps. For example, finding the TI report, threat intelligence report, preparing the simulation task, automating the tasks, and observing the defense activities. So it is slightly easy for everyone. And the tools are shared. That's why we can see actually some of those tools to be delivered to the defense people, which is great in this case. So I prepared a certain exercise for it, TA505 Plus Adversary Simulation Pack. This pack has been designed for TA505, which is a threat actor actively targeting Australia or APEC area or USA. So simply, they are quite active. They perform some cyber espionage operations. They provide some ransomware operations. They try to collect some money. They try to actually resell this information to different parties as well. I was interested in this threat actor because they were targeting the financial institutions, and I was in the financial industry for 3.5 years to identify some of the issues, simulate activities. So it was a kind of certain interest for me. And that's why I prepared a simulation for it. However, the simulation is not based on the threat intelligence reports because we know that they evolve, they provide different tools, different techniques after each campaign. So they learn. So we need to learn as well. So I tried to say that, okay, what if TA505 Plus targets a cutting-edge environment that we can utilize? For example, Windows 10, Office 2019, all the defense tools activated, Windows Defenders enabled, activated, cloud activated. Everything is activated and up to date. So simply, you have nowhere to hide. But again, you need to use open source tools and existing vulnerabilities. You can't utilize a zero-day. You can't use a new technique that is in your pocket and you're waiting for it, right? So I tried to prepare this exercise in that manner, and I used this exercise to bypass all these security controls, try to generate this traffic for you, and prepare this. Good part is this exercise is ready to go pack, so you can use this as a red teamer, you can use this as a blue teamer or a purple teamer, and you can use this as a kind of advanced analytics person or specialist as well. So simply you can take the different portions, or you can make it a collaborative exercise for all parties. So it is free to go. It is actually based on a certain C2, which is Patak C2 and also malware. Patak is another tool I developed last year, and actually the year before, but last year I published this tool. It is a command and control server with a malware, which is an implant. We will call it implant from this point because we will drive it. So whenever I use malware, I will refer to malware activities of it. But again, it is an implant, so we can simply drive it. We can remove features if we don't need to, and we can actually customize this. Patak means weirdo in Klingon. It is there because it was my first C2 and implant generation in C Sharp. Before that, I have developed, say, different C2s using Python, Lambda, DynamoDB on AWS tools and distributed networks. But this one is special for the defense teams because I was planning to automate some activities. So it has automation capabilities, which is great. Other than this, for the execution part, it supports .NET assemblies, .NET source code, and it can utilize some of the other tools, third-party tools. For example, if you like, for example, SpectreOps Ghost Pack, you can just load those tools and run in memory and generate all of the output in an automated way as well. Moreover, it supports normal commands, PowerShell in system automation perspective, and it can support process injection in different types. So it is good for this type of activities to run. So it generates a lot of TTPs on the endpoint. But also it has additional features for the lateral movement. For example, WMI can be used to compromise a remote host, right? You can use WMI to do that. And it supports native WMI connections to get code execution with credentials. But also it supports nested implant perspective. So simply, whenever you have deconnect with one certain implant, you can use the other implants as well through the same implant, just like the Cobalt Strike or other activities. You can just deploy and then link it to the original implant. And you can actually deploy another implant and you can link it to different implants. So simply, you may have access to the implants in your console, but you don't need to know how they're connected. You already designed this and you run it. So simply, you know that implants will drive this through the way. For example, if you have an instruction to the implant, let's say D, in the back through the WebSocket connection with the original implant, and then the second connection, SMB name pipe to the implant A, after that TCP connection to B, and another one to C, UDP connection to D. So instruction will arrive to D directly because there's a kind of pass-through here because of this nested implant feature, which helped me a lot, especially for the air-gapped networks or similar isolated networks. It helped me to deploy the tools and tactics and etc. So take a look at that. One other thing is quite important, scenario-based approach. Whenever I run a red team exercise, defense people generally ask me to replicate this again and again for different reasons. To check the telemetry, to understand the activity, lots of reasons. So I added a feature here, which is scenario automation. So simply, you can make all these instructions HTTPs. Sorry. You can make all of these TTPs. Then you can actually make it a scenario as well. So it's up to you. Then you can just run the scenario and you can see all the activities again. And you can check your telemetry, you improve it, you tighten this up, run the scenario back again. Less effort using the realistic C2, and it is not so different than, for example, Covenant or Mythic or Cobalt Strike. It is, of course, immature because developed by one single person in free time. So that is the downside of it. So I use this in the actually TA505 exercise, and TA505 exercise is quite realistic, especially if we compare with the latest campaigns, for example, Solarigate and the other campaigns of Nobelium. We simply prepared an Exile file. Exile file is using Exile4 macro, and that is running on Exile 2019. And it simply uses a process injection to run our Patak dropper. It uses ExileNT donut to generate this type of activities. So ExileNT donut helps us to generate a certain Exile4 macro that we integrate to an Exile template we found on internet. And ExileNT donut is utilizing donut for us, and it is compiling a C# file we developed. So existing tools, I'm not generating any data here. I'm not saying that I use a magical technique that can utilize this Exile file in a certain way to run my code. No, I use donut, I use ExileNT donut, I use Exile. So that is the good part. The custom part is Patak dropper. Patak dropper is also simple though. It actually gets the environment and it says that, okay, if it is my environment, let's download the MC bypass from the remote. So you have this type of deployment traffic. So that is the actually second stage, because stage 0 is the Exile file, stage 1 is the dropper itself, and it gets to stage 2. It disables MC using MC scan buffer patch. It is coming from also Daniel Dagan Rasta mouse. So it is a well-known patch. I only tune this up to still make it valid for the current Windows Defender. You can see that minor adjustment in the document as well. After that, HTTP download, another HTTP download for the Patak itself, which is implant, which is the actual malware. We will run all this exercise. And then this malware connects back to our C2 using a WebSocket. So it generates different layers for you. If you are a purple teamer and if you are looking for indicators, you can plant flags to different stages and you can say that, dear defense people, did you see this, how it works, and etc. So it helps to everyone. So you have multiple options here for the HTTP download, malware retrieval, or you can use WebSocket as interactive activities. However, when we deploy this, the things change because when we deploy this, we use actual activities on this implant. So this implant actually forks itself on the same host, and it actually listens to the SMB name pipes and TCP connections. I understand that that is the same endpoint still, but they are network activities for you. If you don't actually monitor this, that is a kind of challenge. When we deploy implant, we will have a different type of connection because we will have WebSocket, but this time the implant will be connecting to the internals. So simply we will actually fork the implant to generate different implants on the same host, generating SMB name pipes or TCP or UDP connections inside the same host. They are called network activities and malware communications again on the same endpoint. And you may have a different visibility there. So that is your way to understand how it works. Another one is we will compromise the servers. So in this case, it generates you different types of activities. You can use actually scheduled tasks using the command console. You can use any other command tools such as PowerShell Invox and etc. I use WMI in this case because WMI is slightly subtle. Actually, it was slightly subtle last year. These years, actually this year, everybody is using WMI for everything. So simply, you have some remote compromise options for the lateral movement. When you compromise using the known credentials, you may have an option to actually deploy your implant there using similar protocols, such as SMB name pipe through the SMB DCRPC. Also, you can deploy your TCP and you can deploy your UDP. Moreover, I actually forked this and I deployed another type of implant, which is called Metarpeter. Metarpeter is part of Metasploit framework, and Metarpeter is useful in this case because TA505 was using TinyMet to actually deploy Metarpeter and sometimes utilizing Metasploit through the SOX proxy. It is so noisy. It is generating a lot of activities for you, such as discovery activities, scanning activities, and the other content there. So that's a kind of challenge for everyone. But the thing is, I have actually supplied some commands for you. And I have also some certain systems behind of it because they are supplied as also a vulnerable Windows server or a vulnerable Linux server. So you have some options. So you see the communications here and different types of communications because Metarpeter is even using a different types of HTTP, HTTPS connection. You see the SOX proxy and you have remote deployment here. So in this case, we see different types of connections with different types of telemetry and indicators of compromise. We can deploy our tools everywhere. However, this is not always easy. So for the defense perspective, we need to make it a scenario. I also prepared another scenario video. You can find it on my YouTube channel as well through this link. So simply, we work on a user, which is Padme, on Mandalore, which is an endpoint, and we actually allow Padme to run the malware, the implant, which is Patak C2, Patak malware in this case. It connects back to the Patak C2 service, and then we try to actually compromise this, actually compromise the other servers, this network. In this case, we don't know how it works, so we try to compromise them one by one, such as Coruscant, or we try to compromise GNOSys, and after that, maybe we can compromise also another GNSys implant inside as well. And of course, this network can be compromised in another way, and for example, Nebu can be compromised. So this type of scenario is already demonstrated. It takes more than an hour, unfortunately. I can't fit in exactly in this talk. Please watch this video and try to understand how it works. My simple summary here is, as you see in the map, we simply use Padme as an initial compromise, connect back. Then Padme connects to the correspondent using the SMB name pipe and a WMI code deployment using the well-known credentials extracted from Padme. Also, actually connects back to the Genesis using another TCP connection. So another implant link is there. And in Genesis, we fork another implant there as well, because we may perform some advanced activities. Advanced activities, and those activities need some implant connections. So that is highly important for us. We need to understand that part. That's why we actually sacrifice that implant. Whenever that implant goes, we are away. And we are fine, because we have another implant running on the same system. We don't want to link them to our original implant, because we don't want to lose things and connections. We don't want to use additional traffic here. So we use SMB name pipe in the same network and same host loopback interface. Apologies for that. And Nabu. Nabu is also another system. And this time we use UDP there. I demonstrated different types of connections here, SMB name pipe, TCP, and UDP. The reason is actually, you know that the networks can actually be separated. Some certain protocols will be allowed. Sometimes only Windows protocols, sometimes UDP, sometimes DNS. So we can use different types of protocols to generate these IOCs. Another type of challenge here is actually the network isolations, but we need to have scenario, right? But it doesn't work exactly like that all the time. As you see in the demo, it takes more than an hour, 1 hour, 15 minutes or so, even for a quick demo of multiple compromise. Planning this, automating that, asking consent or maybe permissions to compromise those servers, organizing the software, making sure that it runs under these conditions, organizing the red team or blue team, it is so time consuming. That is one of the challenges. The second thing is, we don't exactly know how it works, because we are purple team, all right? We try to simulate a certain threat actor. But the challenge here is, we don't know exactly what is the motivation of the threat actor in that targeted environment. So we will be threat actor specific as much as possible, but we don't have their actually intents and objectives in our mind. Evasion is a priority for the real-life exercises. In this exercise, yes, it is as well. Also, lack of communications. That always happens. Even though we are in the same room, even we discuss everything, even we give the samples, we shouldn't expect the blue teamers to understand everything happening in that exercise, because their mindset is different. They try to understand the attack vector and how to detect them. On the other hand, for the red teamer perspective, we will try to understand how we can go to the objectives directly. So these type of things are slightly challenged in this exercise, and it is time consuming. Also, it is harder to run, because whenever you need to repeat this exercise, you will be in trouble, because the deployment will change, and the environment will change, and you need to repeat this exercise. But exercise takes time. Even though you automate this, you need to organize maybe 5 different systems for it. So it is not always easy. Moreover, it is not always easy to take, let's say, 5 or 6 systems from the production, especially the certain locations you always see or you always know. That's not possible. And what we see here is, generally the organizations give you those systems on test networks, or they designate 1 or 2 servers. So as a blue teamer, you know that you monitor those endpoints and servers. What if this happens in your production deployment in cloud? That's a question. But there's no certain answer here, because you may not be able to deploy a tool there. You may not be able to deploy a certain malicious software there. You need to send something harmless, and it will be easier to get the consent and permissions or actually service changes there. So these type of things are challenges of the purple team exercises. One other thing is, we always assume that purple team exercise tools are available to blue team. That's not true. Even though most of the tools are open source, we shouldn't assume that the blue team is always aware of those tools and run them accordingly. Because some of the tools are not available, such as some commercial C2s, including Cobalt Strike, but there are also some other subtle C2s in commercial and closed source as well. And we don't have access to, and blue teamers won't have access to either. So we need to replicate them using open source tools. We shouldn't expect the blue teamers to know all the C2 types, Covenant, Mythic, or Patak, whatever weird C2 appears in the wild, because they are used by threat actors, but this doesn't mean that blue teamers should know everything happening in those C2s, because they have different concerns such as data analytics and directions, right? So we have another approach for this, automated traffic generation. Automated traffic generation will help you to simulate the same traffic or similar traffic using different protocols in distributed networks without a hostile intention. None. So simply you can just deploy an implant, but implant will be an open source, maybe hundreds of lines only, and that's it. It will connect back to a certain C2, or it will just download a file as a config, and it will run those communications. It will be a beaconing ratio, for example, every 5 seconds or 5 minutes, it's up to you. There will be some intervals and randomization there to provide you a good median or good coverage for the beaconing ratios. So you need to perform this on TCP, WebSocket, UDP, normal HTTP, HTTPS connections as well. You need to support C2 profiles. So all these answers actually are provided by one single tool that I will refer to you shortly. So what we do here is actually finding a threat actor intelligence report. Again, just like the purple team exercises, we prepare a scenario this time. And scenario is based on only communications, not indicators of compromise on the endpoint, and we will build some C2 profiles for it and observe the defense behaviors and telemetry and data sources. Then we will go to the first step again, and we will use another one. It is so easy to deploy and easy to get approvals, and the generation will be so easy. However, the networks are not always easy. As you see in this diagram, we may have working from home environment, we may have cloud environment, we may have remote deployments, we may have internal network. Moreover, virtualizations and different types of hypervisors will be deployed remote or local. So there are different types of networks here. You can't compromise, or you can't allow a third party to compromise, all right? But you need to defend them. You need to provide a sort of telemetry there. So the solution here is actually using something less hostile to run this type of activities. That is my intention and how I design. So through this tool, we may be able to cover some of those traffic, maybe all of those. Where it is not sufficient, you can always use Patak, for example, assembly named pipe or TCP and other UDP activities or internal activities. But TSAT is slightly easy to deploy, and it will give you more options in that case. So I see also another thing here. I have provided two different research. One is for C2 communications in the wild and their future predictions, and the other one is malware simulations in the distributed network. So in this case, I actually worked on the first paper, and I tried to understand how this type of deployments work. What I observed is some of the threat actors are actively actually using distributed networks. They don't need to actually reveal their hand. Otherwise, they can't actually run the operation for a year. That's not possible. That is how Nobelium works as well, using a certain C2 for only registration, and then working on a certain C2 that can only deploy the second stage, and another type of C2 that gives you interactive communications. So different types of protocols run here: DNS, normal HTTP, and maybe HTTP, WebSocket, or similar tools. We have options here, but of course threat actors have options as well. What I observed through the threat actors is they try to identify the target first. That is most subtle communication. They may use different types of things, but first one is C2. Second one is social media. And third one is some communication channels such as Slack or YouTube or maybe Office 365 communication channels. They try to get an indication of the target is our victim, because we have the code execution. but we need to understand that that is our target. If not, we can resell it. Or if we are a reseller, we can identify the target and we can put a value around it, and then we sell this to different parties. So this is how it works. This is real life. So simply, we need to understand this initial discovery part. For example, Turla was using Britney Spears' Instagram posts to discover the C2 itself. So it was slightly subtle, and you will see only a malware going to the Instagram. Then C2 appears elsewhere. In this case, the malware will need deployments, stages. Do you remember TA505 had the stage deployment? Do you remember the real-life Nobelium deployments, such as ISO file or other files? Exactly, that's what I meant. So they have different servers. Different servers will be located in different positions as well. The implant registers itself if target is correct. And then actually it asks that, do I need to load a feature? For example, do you need process injection? Do you need situational awareness? Do you need, for example, remote communications or lateral movement features? If so, I will go another website. So we are not, again, placing everything in the same bucket. We go to another deployment. For example, a kind of image website. All of those are JPEG or PNG images or job posting. Okay, they are there as implant features. So your implant downloads this and loads in memory and extend it. This part will be actually this part will be an exercise topic for me. And during my tradecraft development workshop in this Hack in the Box Singapore, I will demonstrate this part with you, develop a malware that can extend and grow in memory using C# features. So simply, we don't need to deploy everything in the first place. We don't need to push everything again and again for each TTP or each command. Instead, we grow in memory. New features, for example, process injection capabilities, evasion capabilities, or some other capabilities. So I will develop this live as well. Let's go back to deployments. So we actually deployed different stages to this malware. So we grow in memory, and malware is aware of that different types of connections are there. But we always need interaction. Interaction must be in real time as well. But it is always detected, because interaction means we have a beacon going on a certain ratio, certain beaconing ratio, certain interval. So we need to understand how we can make this realistic and blend into the network communications. The answer is WebRTC or WebSocket or similar real-time activities, HTTP2 or HTTP3 or QUIC protocols. So those protocols are real-time already. So it is normal. We don't need to see a kind of HTTP web page recursively getting the content, or we don't need a kind of certain website always checking for every 5 minutes. We can't do that always. That's why threat actors don't do that either. But we need also real-life speed, real-life traffic there as well. And those protocols, QUIC, WebSocket, WebRTC, that gives it to you. You can just tunnel it, and then you are good to go. However, you can't use any of those channels for data exfiltration. The problem there is we don't know how big your data. You may leverage the organization's capabilities already because your target already has these capabilities, such as AWS, such as Google, such as Gmail. So you need to develop different modules that can utilize data exfiltration slowly to the cloud services already deployed in a client. So the client won't notice that there is also an additional data going to the same cloud service for a different tenancy or different container, which is the attacker in this case. So that is how real life works. Different types of communications, different reasons. And distributed C2 is always a sort of reality. You can deploy similar tools like that. For example, Mythic C2 is a distributed environment. It can help you to do that. Or you can develop your own implant that can support this type of approach that I will develop using C# in our workshop in real time. So we can see how it works for the C2 perspective. Tesat malware generator is actually for defense people and say cyber data analytics people. So you don't need to code anything. You don't need to work on tools. You don't need to actually work on all of those offensive capabilities, you need to focus on what you want to do. Simulating a network traffic. That's it. And you have just one single portion of it. I know it looks like it's oversimplified, but it helps you a lot. You can create multiple services on this TESAT interface, and you can use multiple implants coming from different places or the same host, and that will be realistic as well. TESAT is also another language, Vulkan, and it means deception. So I try to actually provide you slightly similar data generation environment. But again, you need to read the threat intelligence reports, and you need to extract this data. So it gives you a graphical user interface this time, not the console interface, not a hacky interface. It supports currently HTTP WebSocket with HTTPS support as well, and TCP UDP. Easy customization is available because you can easily see the menu, and the menu allows you to change the get post request, get post type, or HTTP headers or user agents. So you can make it realistic as much as possible. You can use the same request. You can use a get request, post request. You can use stages. So it's up to you. Service creation is based on a profile, C2 profiles. So you create a profile, and then you create a service based on the profile. So you don't need to repeat yourself for each service. You can use a profile that can fork to multiple services running on different ports for different reasons as well. So that is slightly useful. And implant generation is so easy because it generates the implant for you. It gives you the source, so you can just use a .NET application to run this. It is .NET 5, by the way. So you can use this tool anywhere .NET 5 available. The server component as well as the implant component. Scenario and design steps are so simple. Find the threat intelligence report, read it, understand the content, and then replicate the kill chain phases of it, and then actually generate this traffic using the profiles. Okay, that is so easy. The interface is also easy to understand because the interface is giving you multiple options, generating profiles, generating service, and then during the profiles, you have options. So not only names, the ports, the URL types, URIs, the data content, or HTTP headers, or user agents. So you can use every portion of this HTTP request as an indicator of compromise. So you can use data transfer in user agents, or you can use data transfer in the content itself. So it's up to you. The set simulations are slightly easy to understand, but it is also so customized. So it's up to you again. TESAT can actually simulate multiple traffic. In this sample scenario, it can actually provide the HTTP serverless communications, maybe ICMP. It is under development, by the way, DNS as well, HTTPS and HTTP. So simply a reseller would compromise this network and use HTTP beaconing for it. And whenever it finds another threat actor who can buy it, it sells this network communication. So you have another type of beaconing to another threat actor, and then it changes the C2 type, for example, WebSocket, and it connects to your network and uses TCP and UDP. This type of scenario could work with TESAT. One single implant type deployed one-where, and TESAT could be on maybe a cloud service, and it will generate these IOCs for you. It is not hostile. That means you can deploy this to anywhere, even cloud services. You don't violate any NDAs or something like that. You have no concerns because it is not an hostile tool. It doesn't actually drive a malicious implant. It simply generates traffic. It sees that, okay, I received this traffic. Traffic is this. That's it. So it is easy to get this type of approvals. You can plant the flags inside the communications as well. You can put some certain strings, and you can say that, okay, blue teamers, you identified the C2 because domain is so obvious. Can you actually see the content and the flag? Can you give me the flag itself? That will actually enforce them to find the actual flag and actual problems there, okay? So C2 communications, lateral movement, data exfiltration, they all may have flags. I actually like tool Vector here because Vector gives you interactive communications and management capabilities for this as well. So again, it's up to you. Every run has some consequences. So uplift your game and try to add more layers. For example, implement domain fronting, implement newer protocols. And I will try to do that for you as well. But again, Tesat is my open source play tool. I try to do that in my free time. Whenever I find some free time, I add new protocols and new features. Currently, it comes with 2 different white papers for you and this tool as a proof of concept, but you can easily deploy your own protocols there. So this is a sample demo for Tesat and how it works. So simply, Tesat is there as an offensive tool, but we need threat intelligence data. In this case, we use Security Bulwark blog by Eric Helmvig. So simply, in this tool, we see how it works. During this tool and during this environment, we understand that ICE ID was a ransomware. And this ransomware generates some certain IOCs. And this ransomware is actually generating some HTTP traffic, HTTPS traffic for certain reasons, get and post type of it. So simply, we see this, and this is how it works. In this demo, I will try to show you how a Tesat malware generation works. So Tesat is the tool, that was the interface, and now we are looking for a security threat intelligence blog in Security Bulwark, and Eric Helmvig has provided some data about ICE ID, which is a malicious software. A ransomware actually generates some different types of traffic for different reasons, for example, C2 deployment, C2 communications. So we need to understand how it works, right? As a data analytics or blue teamer, we can always access your threat intelligence data. This is an example. So we see that text or that get request or post request will give us some indicators of compromise. So we will try to generate the same thing in our environment. That's why we used ICE ID and Cobalt Strike example, because ICE ID was using Cobalt Strike to deploy. And we don't have access to the Cobalt Strike because it is not always available, because it's a commercial application sold under certain conditions. And in this profile, we can choose our profile options, such as ports, such as HTTP URI, such as the get or post request type. We can add headers, we can remove headers, and we can do more and more. So it's up to us. So simply, we can actually use all this content with some certain generation capabilities. So it's up to us. Another thing is we can actually make it realistic here, and we can copy and paste, or we can just generate the content, whatever it is. In this case, I'm actually mocking up. I'm providing a content that will be not the exact response, because we need threat intelligence data to see that. And the current blog doesn't have exactly how it works. So I say that, okay, if that URI is used, I can give some instructions. So it's done. Another one is also the post request. So Cobalt Strike can use multiple request types for different reasons, such as Cobalt Strike deployment, the beacon deployment, or normal GET request for the tasks, or data transfer for post. Or it can be also GET as well. So it is really important for the malleable C2 profiles. In this environment, we have all options. We can actually provide different GET requests, or we can use actually different types of response data. So this is task data processed, and we are actually receiving an input from the implant saying that, yes, I executed these tasks, this is my output. And the server says that, success, I got it. These are the profiles. Let's generate some services for it. The service name is same again, ICE ID and Cobalt Strike. And this time, it is the ports are important, because that was the template, the initial one, the profiles. This time, we can change things here. And this will be the service itself, because you would generate the implant based on service, not on the profile. So the profile is your template to generate multiple services easily without any change or with just minor changes. But the services, whatever put on the services, will be reflected in the implant. So our implant will have all these. There are 2 services running here. When we actually click play, it will start running. So we have 2 different services for 8001 and 8002. Now we need an implant for it, right? So the implant needs to be generated. So implant generation is under implants. So I'm generating an ICE ID ransomware implant for it. The domain, Tesat may not know the domain, so you need to give it because it may be running on a cloud on an IP address or a domain. I use the local host for it, so it will be easier for me to show you and replicate. But again, in your environment, you may need to tell the implant that is the domain Tesat running, so go there. And that is the port as well. Also, you can decide what type of update interval or jitter should be used by that implant, because it is custom, because that is the implant specific thing, not driven by the Tesat malware generator. As you see, this is the source code of it. You can download this as an implant source code. It's a .NET project. What you need to do is only using .NET run. That means it will run the implant. That's it, because it has only one single program CS with some limited tool and limited capabilities. I'm opening the Wireshark to understand that how our loopback interface observes this traffic. I will also limit this traffic to the traffic we actually try to monitor and understand, which was port 8001 and port 8002. So we will see that how this traffic has been generated on this network, which is loopback interface for now. But of course, you can use remote deployment. So our implant is actually simply connecting now, and we have services already running. So we can use the status screen to understand how it works and what's happening. As you see, implant simply shows you that this is the server's response. These are the other server responses, and etc. But simply, you see the content on the implant side. You need to see this on the network using your telemetry and data sources, right? That's why you need to go back to the Wireshark to understand that how it is reflected. As you see, it is here, and it is used as a normal traffic. Whenever you actually follow the TCP stream, you will see the raw request. And it is easy to understand because that is simply the data generated and to be observed. So this is how it works for Tesat malware generation. The implant and the server, and they generate output for you. There is nothing malicious here, no code injections, no code execution on the remote side, but .NET Run will make you confusing, for example. You can actually compile this as an executable, or you can deploy this using PowerShell. It's up to you. But deployment strategies must be discussed because that is specific to you. I'm just giving the tool, not the deployment strategies for you. But my suggestion is use cloud deployments. Use domain fronting in front of Tesat malware generation because you may have different options here. So it supports you to drive some certain headers or some certain content. And you can always monitor the implants and their connection types. This is how it works for the Tesat, actually. So I hope you like Tesat. The conclusion here is malware traffic simulations are actually prepared using threat intelligence data. You need to understand that part, and that is certain. Second thing is you actually need to utilize some adversary simulation packs for the collaborative exercises. If there is no game plan, if game is not ready, tools are not ready, it is not efficient. Another one is distributed C2 approach is quite common these days. So pay attention to different types of protocols, how you can monitor them, not only HTTP, not only traditional domain mapping, social media, cloud services, HTTP, HTTPS intersection. Try different options using Patak and Tesat. Malware generation, actually traffic generation can be also automated. So it's also up to you. These are my tools and references, and I will be more than happy to support you in this case. Feel free to reach me out. But also, thank you for joining me today. Thank you, Hack in the Box Singapore, to actually invite me to speak here again. This is our Discord settings. So simply you can use this Discord invite to actually join Discord and work with me on your questions and your options. Thank you for your time. Thank you, Hack in the Box, and thank you, audience. Have a great one, and see you in Discord.